We are back today with our Prism Caribbean mathematics video. I am your tutor, Jordan Jaffa, and today we'll be going through some matrices, right? Just to point out, based on the last video, if this wasn't mentioned already, the null matrix, apologies for my handwriting, is given as 0, 0, 0, 0. So maybe sometimes in the exam they might ask you what type of matrix is this, maybe in a multiple choice, or maybe in the paper 2s they might ask you to add two things where somehow they get this matrix and then they ask you what is this matrix called. So this is the null matrix, right? And just to go over the inverse concept, right? The inverse is given as 1 over the determinant. So let's say the matrix is A, multiplied by the adjoint of A, right? So in mathematical terms, this is basically 1 over the AD minus BC, which I saw in textbooks, and so it's something important to learn. And the adjoint would be, in this case, D minus B minus C and A. Now, where did these letters came from? Let's say A is equal to A, B, C, D. Then the adjoint will be simply this here. We switch leading diagonals and we place a negative by the other diagonals, right? Something very simple to note. Please don't forget that. That's some good marks to get in the exams, right? And also in understanding the concept. So you must know this, right? This isn't anything long, actually. This is just one part. You can just learn off this part alone, or you can just learn off this. It's really the same thing, right? So now let's get to maybe a practice question. I would like to go through finding the inverse again. I think it's a really good topic to take note of, right? So that's we are finding the inverse. So let's say we want to find the inverse of inverse of 3 minus 2, 4, and 1, right? That's the matrix we want to find the inverse of, right? So what we basically do, we find the determinant. So let's call this matrix A, right? So the determinant of A will be equal to 3 by 1, which is AD minus BC, which will be 3 minus, and then we have 4 by negative 2, which is negative 8. Right, which will just be 3, negative and negative is positive 8, which will just be 11, right? And we want to find the adjoint now. Remember, for the adjoint, we switch the leading diagonals and we make the other diagonal negative, or we just multiply by negative 1. And I will explain that moment now. So again, we switch the leading diagonal, we make the 4 negative, and we already have the 2 as negative 2. So when we multiply the negative 2 by negative 1, because we essentially multiply that diagonal by negative 1, right? So it will be negative 2 by negative 1, which will just be 2, right? So therefore, the inverse is equal to 1 over 11, 1, 3, 2, negative 4. Now, you might be wondering, where did this fraction come from? It must be important to note that the inverse is given as 1 over the determinant of A by the adjoint. And that's it, right? With regards to the determinant, right? So let's move on to something new. I'm going to get back to inverse again. If you don't understand the concept as yet, just replay the video, go over it slowly, you should get it. Again, step 1, find the, nope. Step 1 is find the determinant of A. Step 2 is find the adjoint of A. And step 3 is just place it in the formula. And there you go. You have the answer right there. And that's it. So now we're going to get to an application of this. Alright? Again, I'll be doing all these in a past paper. Maybe I may do 1 or 2 questions depending on how the past paper comes, right? So let's say we have 2 equations. 3x minus 4y is equal to 1 and 7x plus y is equal to 23. Now in the exam, of course, there are many ways to solve this. We can use simultaneous equations, we can use the matrix method. However, if this topic falls under the topic of matrices and vectors, we of course know we have to solve this using the matrix method, which it isn't hard. It's quite simple. Alright? So let me just get this here. Right. So let me just change this color. Right. So yeah. So solution. So we want to find x and y, right? So yeah. So what we first have to do is that we have to put this into a matrix form. So the matrix form will be 3, negative 4, right? 3, negative 4, 7, and 1. Where we got those numbers, we just use the coefficients next to each letter, and we put it in its respective locations. And what we are multiplying it by? X, y. And what are these solutions? 1, 23. That's it. I mean, this is just the beginning, but once you have this step, you know you're on the right track, right? So let's put this in terms of a context now. We can put this as matrix A multiplied by, let's say x in this case, is equal to b. Now with regards to matrix, it's not going to be x is equal to b over a. It's x is equal to a inverse by b, right? Got that? So x is equal to b, x is equal to a inverse, okay, let me just fix that. By b, right? And simple. So in this case, what it says is that first we find the inverse of a, and what we get for the answer there, we multiply it by the matrix B, right? So okay, yeah, so first let's find the inverse of A, right? Again, inverse of A. So we first have to find the determinant, which we know is 3 by 1 is 3, minus negative 4 by 7 is negative 28, which is 3 plus 28, which is equal to 31, right? We're keeping that simple there. Then we find the adjoint. Well, we know what the adjoint is. You switch these sides, the leading determinant. We switch the numbers there, and then we multiply the other diagonal by negative 1. So the 1 and 3 are switching positions. It will be 1, 3, and the leading the other diagonal we multiplying it by negative 1. So it will just be negative 7, which is 7 by negative 1, and negative 4 by negative 1, which is just simply 4, right? And we of course know the inverse using the formula will be 1 over 31 multiplied by 1, 4, negative 7, 3. And that's just it there for the inverse of A, right? But remember, we also have to multiply by x to get the 1 over 23, and we need to find the x and y. So in this case, we revert to this formula to find what the x and y is, right? So we know x is equal to A inverse by B. By the way, x is not just this x here, x is this entire matrix, right? So I would just say in this case xy, right? Just to make it clear for those who want to see it a bit better. Then we put the inverse matrix of the A, right? And then we multiply by the matrix B, which is 1 and 23. So we know xy is equal to 1 over 31, right? And we have this matrix multiplied by this matrix. We know we go with the simple measures, first by first, second by second, just so I taught it in the last video. And we should be able to get 1 over 31 by 93 over 62, which will in this case give us 3, 2, which is equal to x, y. Therefore, x is equal to 3 and y is equal to 2, right? And using this solution here now, right? Yeah. Using this solution here where we have x is equal to 3 and y is equal to 2, we can plug it back into any of these equations here, and we should be able to get the answer as given in the question, right? And with regards to matrices, the only topic that has to be done will be transformations. Otherwise, everything else has been done. And this is basically matrices. It doesn't get really too hard from here, of course. It's just the application of it that really matters. And of course, repetition of the past papers, we can only get better. Which I will do a past paper to come soon, right? However, so ending this video, I am Jordan Jaffa, your tutor for Prism Caribbean Math. It was a really good session. I'll see you in the next video. Thank you.